In 2006, Pluto was reclassified as a dwarf planet. For many people, that made it seem like a small, frozen object that no longer mattered very much. But when NASA's New Horizons spacecraft finally reached Pluto in 2015, it changed that picture completely. Instead of a dead world covered only in old craters, it revealed glaciers of nitrogen ice, mountains made of water ice, a thin blue atmosphere, and signs that Pluto may still be active deep inside. Pluto is small and distant, but it turned out to be far more complex than most people expected. My name is Neil, and in this series I test worlds for long-term human survival, not as fantasy, but as engineering. In every episode, I break down 4 things: the environment, the main risks, what might make survival possible, and a final verdict. Today, Pluto. Pluto is a dwarf planet in the Kuiper Belt, far beyond Neptune. It is about 2,377 kilometers across, which makes it much smaller than Earth's moon. It also sits incredibly far from the sun. At that distance, sunlight is very weak, more than 1,000 times weaker than what we receive on Earth. The sun would still be bright if you looked directly at it, but it would no longer dominate the sky the way it does here. Pluto is also extremely cold. Surface temperatures are often around -225 degrees Celsius, or about -375 degrees Fahrenheit. At those temperatures, familiar materials behave in unfamiliar ways. Nitrogen, methane, and carbon monoxide can freeze into solid ice on the ground. And ordinary water ice becomes so hard that on Pluto, it acts more like rock. From far away, Pluto once looked like it should be simple: small, frozen, and geologically dead. But the first close images showed something very different. The most famous feature on Pluto is the bright, heart-shaped region visible from space. This region is called Tombaugh Regio, named after Clyde Tombaugh, the astronomer who discovered Pluto in 1930. Its western half is a huge basin called Sputnik Planitia. Sputnik Planitia is one of the strangest places in the solar system. It is a broad plain filled mostly with nitrogen ice, along with methane and carbon monoxide ice. What makes it especially important is that it has very few impact craters. That matters because crater counts help scientists estimate how old a surface is. In the outer solar system, very old terrain is usually covered in scars from impacts over billions of years. But Sputnik Planitia looks young. That suggests the surface has been renewed over time. In other words, Pluto is not just sitting there unchanged. Something has been reshaping this region. One leading idea is that the nitrogen ice in Sputnik Planitia slowly flows and overturns over geological timescales, a bit like very slow convection. It does not move like water, it moves much more slowly. But over long periods, it may be enough to erase old surface features and keep the plane looking fresh. So Pluto's heart is not just visually interesting. It is one of the strongest signs that Pluto is more active than we once thought. At the edges of Sputnik Planitia, the landscape rises into mountain ranges. On Earth, mountains are made mostly of rock. On Pluto, some of them are made largely of water ice. That sounds strange at first, but it makes sense in Pluto's extreme cold. At such low temperatures, water ice becomes very hard and rigid. It can support cliffs and mountain-sized structures the same way rock does on Earth. Some of these mountains rise several kilometers above the surrounding plains, and in some areas, large blocks of water ice may sit within softer nitrogen ice, almost like giant icebergs in a much denser frozen material. This creates one of Pluto's most unusual contrasts: hard water ice mountains next to smooth plains of nitrogen ice. On Earth, we think of water as soft, flowing, and temporary. On Pluto, water forms part of the solid framework of the landscape. Pluto is not just white and gray. Parts of it are reddish or dark brown. That color likely comes from complex organic molecules known as tholins. These form when sunlight and radiation interact with gases like methane and nitrogen, either in Pluto's atmosphere or on its surface. Over time, this chemistry creates darker, reddish material that settles onto the ground. This is one reason Pluto looks so visually complex. It is not a single-color frozen ball. It has bright plains, darker regions, layered surface chemistry, and strong color contrasts that suggest different materials and different histories across the surface. Its largest moon, Charon, shows something similar. Near Charon's north pole is a dark red region called Mordor Macula. Scientists think some of that material may be linked to gases escaping from Pluto and later being processed on Charon's surface. So even in this distant system, Pluto and Charon may be chemically interacting with each other. One of the biggest scientific questions about Pluto is what lies beneath the surface. For a long time, Pluto was thought to be frozen all the way through, but some evidence suggests it may have, or may once have had, a subsurface ocean of liquid water beneath its icy crust. This idea comes partly from the behavior of Sputnik Planitia and partly from models of Pluto's interior. Some scientists think the weight and location of that large basin make more sense if Pluto's crust is sitting above a deeper layer that allowed the planet to adjust over time. There is also the question of internal heat. Pluto is small, but it may still retain some heat from radioactive elements in its rocky interior. That heat would not make Pluto warm, but deep underground, under enough pressure and insulation, it may have been enough to help maintain liquid water for long periods. We do not know for sure whether a subsurface ocean still exists today, but it remains a serious scientific possibility. And whenever liquid water is possible, one major question follows. What kind of chemistry might happen there over very long timescales? Another surprise from Pluto was its atmosphere. It is very thin and made mostly of nitrogen, with smaller amounts of methane and carbon monoxide. You could never breathe it, and the pressure is far too low for a human to survive without protection. But the fact that Pluto has an atmosphere at all is important. And even more interesting, that atmosphere changes with the seasons. As Pluto moves along its long orbit around the Sun, some surface ices can sublimate, meaning they turn directly from solid into gas. At other times, gases can freeze back onto the surface. So Pluto's atmosphere is connected directly to its surface ice. The ground and the air exchange material over time. One of New Horizons' most beautiful images showed Pluto backlit by the Sun. In that view, the atmosphere appeared as a thin blue haze around the edge of the planet. That blue color was caused by tiny particles in the atmosphere scattering sunlight. It was a striking reminder that even at the edge of the solar system, Pluto is not just a frozen rock. It has weather, haze layers, and active surface atmosphere chemistry. So, could a human survive on Pluto? Out in the open? No. The first problem is temperature. Pluto is cold enough to kill an unprotected human very quickly. The second is pressure. Its atmosphere is far too thin to breathe and far too thin to protect your body. Without a fully pressurized suit, survival would be impossible. The third is distance. Pluto is so far away that any human mission would take many years with today's technology. Communication with Earth would also be delayed by hours, depending on the distance at the time. Then there is power. Solar energy is much less useful that far from the Sun. A Pluto outpost would likely need nuclear power or another reliable internal energy source. Any long-term habitat would have to be closed, insulated, pressurized, and largely self-sufficient. It would need heat, life support, radiation management, recycling systems, and likely underground or heavily shielded living spaces. This would not be a place for an early colony. It would be a place for an advanced scientific outpost, and only if humanity had already learned how to survive for long periods in deep space.